Hello geometers, and welcome back to another video lesson with Mr. Forster. Today we'll be going over solving systems of equations, a little bit of algebra review. Alright, in our first example, we're going to look at solving the following system by all three of the methods that we have, which is A, graphing, then B, substitution, and then by C, elimination. We're going to focus on graphing in this first slide here. So I have two equations. My top equation here is equation 1. The bottom equation here is going to be equation 2. And what I'm going to do with these for graphing, well, I have a couple of different ways that I can graph. For equation 1, this one I'm going to change to slope-intercept. And that is y equals mx plus b. And to do that, I can subtract x from both sides. So if I subtract x from both sides, this is going to look like y equals negative x plus 2. And what that means is I have a slope of negative 1 and a y-intercept of 2. So if I come down on my graph, my y-intercept is going to be up 2 spots. So 1, 2, it's going to go right there. My point there. And then I have a slope of negative 1. So I'm going to go down 1 and over 1. Do this a couple times. Now I don't need to do this many times, but it's nice to have a little path of where I'm going here. So I'm going to go ahead and do that. And then what I'm going to do is my iPad allows me to take a line and pass it through all of these. It'll automatically turn into a line for me. So now I have my first equation graphed out. For my second equation, I'm going to use the intercepts, the x and y intercepts. I mean, I could convert this into slope-intercept form, but it's not the only way to graph these. And based on what we did in first quarter, I know that to make a line, I need 2 points. And the 2 intercepts will give me the 2 points that I need. So if I do this, let's go ahead and zoom in a little bit here. In the first intercept, I'm going to let x be 0. That's going to give me my y-intercept. So I'm going to say let x equal 0. And that means I'm going to have 4 times 0 plus 2y equals 12. 4 times 0 is 0, so I have 2y is equal to 12. Divide by 2 on both sides. And that gives me that y is equal to 6. So this means that I have the point 0, 6 on my graph. So I'm going to come over to my graph, and I'm going to go from 0, and up go 1, 2, 3, 4, 5, 6. So I'm going to go right there. So there's my first point. And then for my x-intercept, I'm going to let y be 0. Next, we're going to let y equal 0. Then I'm going to have 4x plus 2 times 0 now is equal to 12. 2 times 0 becomes 0, so I get 4x is equal to 12. Divide by 4 on both sides, and that gives me with x is equal to 3. So this means that I'm going to have the point 3, 0 on my graph. So if I come back over to my graph, I'm going to start at the origin, and this time I'm going to go 3 to the right. 1, 2, 3. I'm going to have this point right here. And now I need to draw my line through those 2 points. Now that I've drawn my graph, I want to find out where these 2 lines intersect. That's what it means to be a solution of this system of equations, is that it satisfies all of the equations that are in the system. And in this case, there's one spot right here. Mark here in purple, right there. And this point right here where they overlap is the point 4, negative 2. So to recap what we did here, we graphed our first equation, then we graphed our second equation. We used a different strategy for each. In the first one, I changed it to slope-intercept form, or y equals mx plus b. In my second equation, I used the intercepts to create 2 points, and then connected those two. And then finally, I found out where do these 2 lines meet or intersect, and that point of intersection is our solution. So our solution is a coordinate point where the 2 lines intersect. Let's look at our other methods of solving this system of equations. So we have, again, substitution and elimination are our other 2 methods. Substitution means I'm going to be replacing something or substituting in. Typically we do this with a variable. So I'm going to, again, rewrite my first equation, which is x plus y is equal to 2. And I'm going to write it in slope-intercept form. This is going to put y by itself on one side, so I'm going to subtract x from both sides. And what that's going to do is that's going to leave me with y is equal to negative x plus 2. And then what I can do with that is when I go to rewrite my second equation, 4x plus 2y equals 12, what I can do now is, because this y is equal to all of this negative x plus 2, wherever I see a y here, I can replace it with this negative x plus 2. So let's do that. 4x plus 2, and then we're going to put some parentheses here. Negative x plus 2 equal to 12. It's actually really important to make sure that you have these parentheses here because we're multiplying by all of the value of y. Well, y is worth all of this, not just part of it. So we want to make sure that we distribute that 2 across everything that y is equal to. Zoom in to make this a little bit easier to see here. Next, we're going to have, okay, distribute the 2. So 4x plus, actually this is going to be minus. 4x, 2 times negative x is negative 2x, and then 2 times 2 is plus 4 here, still equal to 12. Combine like terms, I have 4x here and minus 2x here, so that combines to be 2x plus 4 is equal to 12. Subtract 4 from both sides, and that gives me 2x is equal to 8. And then divide by 2, and I get x is equal to 4. Now that I have this x equal to 4, I can take this, and now I can substitute this into the x that is over here. So let's do that. I'm going to have y is equal to, let's actually make that red, be consistent in our colors here. Y is equal to negative, and then I'm going to swap in the 4 here, substitute in the 4 plus 2. And so negative 4 plus 2 is negative 2. So we get y is equal to negative 2. Again, combining our two values of x and y, we get our coordinate pair, which is going to be 4, negative 2. Now we've seen two different methods. We've seen graphing and we've seen substitution. Finally, we have this thing called elimination. This is personally one of my favorite ways to solve these. But we're going to go ahead, I'm going to rewrite both equations this time, kind of stacked on top of each other and lined up. So they're already done nicely for us here, where we have x in our first spot for both, y in our second spot, and then our constant is kind of off by itself. This is called standard form, by the way. Just a little subtle reminder, this is a name for this form. It's called standard form. So we're going to put here x plus y is equal to 2, not 12. And then next, we're going to put our 4x plus our 2y is equal to our 12 here. Zoom in so it's easier to see over here. And so in order to eliminate, we need to use either addition or subtraction. And so if we have both of the x variables, for example, have the same coefficient, but are opposite signs, so one's positive, one's negative, or same thing for our y variables. When we add the two equations, which we're allowed to do, we're allowed to add these two equations or subtract them, then what happens is I can eliminate or get rid of one of these variables. So one thing that I noticed right away, mark this in purple here, is that, let's do some green just to highlight this real quick, that this y and this y, well, if I multiply this y by 2, then I would have the same coefficient. Or I can multiply it by negative 2, and then I would have minus 2y, so if I add them together, that the y's would go away. So here, I'll show you what that looks like. I can take this first equation and I can multiply it by a constant. A constant is just a number that doesn't have a variable in it. So I'm going to multiply this whole thing by negative 2. And then I'm going to rewrite that now underneath my second equation. So we'll do this in purple. So now we have negative 2x minus 2y is equal to negative 4. And again, I'm distributing that negative 2 to everything in my equation. And now what I can do is if I was to add these two equations, adding just these two, what I can do with these, if I add straight down, you'll notice that, well, 4x and negative 2x makes positive 2x. 2y and negative 2y, well, that makes 0y. So I don't even have to write anything there, but I'll just go ahead and put 0 there. Is equal to, well, 12 plus negative 4 is 8. So now I end up with this 2x is equal to 8, which we've seen before. So that means if I divide by 2, I get x is equal to 4. Now I could go through the work of also eliminating x and then solving for y, but once I've gotten to this point, especially if I have only two variables and I'm trying to solve for both of them, I don't really need to use elimination a second time here. I really just use elimination to get my first value. Now that I have this first value, now I can go back to substitution, and I can use my x plus y equals 2 first equation, my original equation, and I can substitute that 4 in. So I can take this 4, and I can substitute in for x here. So let's do that. So I'm going to get 4 plus y is equal to 2. And again, if I subtract 4 from both sides, then I'm going to get y. Oops, didn't mean to move that. Again, if I subtract 4 from both sides, I'm going to get y is equal to negative 2. So I still get my same solution of 4, negative 2. So in all three versions of solving this, graphing, substitution, and elimination, I should get the same results. At this point, I want you to pause the video and try number 2 on your own. In this case, keep in mind that it is asking that we use substitution. You can use the other methods as a way to confirm your solution, but I do want you to start with substitution. And again, a reminder that your goal is to find a coordinate pair, which is going to come in the form of x comma y. So it's going to look like this guy right here. Go ahead and pause the video and try on your own. All right, I'm going to go ahead and get started. In my first example here, part A, let's zoom in just to part A here. Well, I already have my first equation, this one, is already in the form of x equals y plus 3. So the one variable, in this case x, is already isolated or by itself. We can see that over here, x is by itself. So what I can do then is I can take this whole y plus 3, and anywhere I see an x, which would be right here, I can substitute y plus 3 in for that x. So I'm going to do that. So I'm going to have 5 times this y plus 3 minus y is equal to 7. And now I can solve for y. I'm going to distribute the 5 and get 5y plus 15 minus y is equal to 7. And combine like terms, 5y and minus y becomes 4y. Plus 15 is equal to 7. If I subtract 15 from both sides, then I'm going to get 4y is equal to negative 8. And then finally, if I divide by 4, then I'm going to get y is equal to negative 2. So I've gotten my value of y. And if I go back into that first equation again, this one right here, I can solve for x by substituting this negative 2 in for this y up here. So I'm going to do that. We'll do that in blue here. So we have x is equal to, and again, my y value, which is negative 2, plus the 3. That means that if I add negative 2 and 3, I get positive 1, so x is equal to 1. A lot less work for that second variable. So my solution for part A is going to be the coordinate pair 1. Actually, do that in blue so we see where it came from. Negative 2. Let's go ahead and look at part B. All right, part B, I don't have it set up to where I can easily substitute a value in just yet. So I'm going to go ahead and look at my first equation again right here. And what I'm going to do is I'm going to add 2y to both sides. So if I add 2y to both sides, I'm going to add 2y to both sides. That's going to give me, I end up with no y's on the left, but I get 2y minus 3 on the right. Now that I have this x equals 2y minus 3, I'm going to substitute that 2y minus 3 in everywhere I see an x in my second equation. Let's go ahead and do that. I'm going to do this, start off in black here. So I'm going to say 7 times that 2y minus 3 minus 2y, make that look like a y here. Good enough. Is equal to 15. So now I need to, again, distribute that 7 across. So 7 times 2 is 14. So I'm going to get 14y. 7 times 3 is 21 minus 21 minus 2y is equal to 15. Combine like terms, I have 14y here and 2y here, or minus 2y rather. So I'm going to have 12y minus 21 is equal to 15. Add 21 to both sides. 12y is going to equal 36. I really need to struggle, or I really struggle with writing my y's. Is equal to 36. Finally, divide by 12, and I'm going to get that y is equal to 3. Now I have my value of y. I can now go back in and substitute that into any of my original equations. We've been using our first equation quite a bit, mostly because it tends to be the simpler one. That's still the case. However, this time, I'm going to substitute it into our modified version. I'm actually going to substitute it back into the y in this version where x equals. That way I don't have to do any extra work to isolate x by itself. So let's do that. This time, let's do it in blue here. X is going to be equal to 2. I got my y value of 3 here. Minus 3. So that means that x is equal to 6 minus 3, which means x is equal to 3. So that means that the solution for this is going to be the coordinate pair 3, 3. And box the solution in both cases. So there's A and B. All right, finally, again, I want you to pause the video, try on your own. This time we're solving using elimination. And again, make sure it's in a coordinate pair in the form of x comma y. Go ahead and pause and try on your own. All right, I'm going to go ahead and dive right in. In our first example, problem A here, we have the system, and again, we have our two equations. They're already stacked on top of each other nicely. We have x is lined up, y is lined up, and our constants lined up in order. So we have our x is here, y is here, constants there. And, well, what I noticed right away is that I already have something quite convenient, which is that I have this negative 2x and this positive 2x here, which means if I add these two equations, I will eliminate the x variable. So let's go ahead and do that. Let's do some blue here. I'm going to add straight down. So negative 2x and 2x is going to give me 0. And then 2y plus another y is going to give me plus 3y. And then negative 2 and 5 is going to give me positive 3 when I add them together. So that means that 3y is equal to 3, which if I divide by 3 on both sides, I'm going to get y is equal to 1. So really nice starting off there, already being able to eliminate x's right away. Now I can use, again, substitution at this point. For me, the simplest one, in this case, substitute back into is not the first equation, but the second. And the reason for that is, well, the y variable here doesn't have any extra coefficients. It's just a coefficient of 1. So I'm going to go ahead and use that second equation to substitute back in. So I'm going to say, okay, 2x plus, and I have y is equal to 1 in this case. That is equal to 5, coming from our second equation here. And then I can say, okay, well, if I subtract 1 from both sides, I'm going to get 2x is equal to 4. And then finally divide by 2, and I get x is equal to 2. So I have these, again, two parts to my coordinate pair, which means the final solution is going to be 2, 1. And there is my final solution to part A. Let's look at part B. All right, part B is a little bit trickier here. This time I don't have anything that lines up nicely. For me, though, the one that stands out as being the easiest to change is if I can get this 3y to look like 6y. I can multiply the 3y by 2, or in my case, I'm going to multiply by... Well, no, you know what? I haven't shown subtraction yet. I'm going to go ahead and show multiplying by 2 and show you what that looks like. So let's go ahead and multiply by just 2 this time. So I'm going to take this and multiply the whole thing by 2. So underneath, I'm going to, again, rewrite below. I'm going to have 2x this time plus 6y is equal to 10. So now what I'm going to do is, instead of adding these two, I'm going to subtract. And again, I'm only focused on these two right here. And to do this, to subtract down, I can do one of two ways. I can distribute the negative in to everything, and then add down, which is what we had done in the past by just multiplying by a negative value in the beginning. Or I can treat it as like I'm subtracting straight down. 4x take away 2x is 2x. Again, 4 minus 2 is 2. 6y take away 6y. Well, that's what I was hoping to do here to get 0 left over, so I'm going to have just a 0 there. Here's where I need to be tricky, and I need to understand my integer operations. I'm going from negative 10, take away 10, so it's 10 degrees below 0 outside. It gets 10 degrees colder, so it's going to be negative 20. So I would say just be careful if you're choosing subtraction. Make sure your integer operation skills are on point. Now we have this set up. We don't need the plus 0 written, so we can say 2x is equal to negative 20. Finally, I can divide by 2, and I get x is equal to negative 10. At the value of x. I mentioned previously, we don't need to use elimination to find our second variable. We can just substitute that back in now. So x equals negative 10, I can substitute back into my first equation, into this x right here. So let's do that. I'm going to say negative 10 plus 3y is equal to 5. If I add 10 to both sides, I'm going to get 3y is equal to 15. Again, that's adding 10 to each side there. And then I'm going to have to divide by 3, and that gives me y is equal to 5. So my final solution in this case is going to be negative 10, 5. All right, that concludes our lesson 2 of Unit 7. The homework this time is actually attached to the notes, so you should see a second page on there that says lesson 2 homework at the top. If you are doing this through the Kami extension in Google Classroom, then you can use that there. You can also print this off and do it by hand. Either one is fine by me, but everything should be available to you in the Google Classroom post if you're in my class, or check with your teacher on where they keep all of their things if you don't have me. So thanks again, and I'll catch you in the next one.